Okay, so a while back now, I mentioned that we have uh, a very significant positive skew in the labels for the length of stay. So remember that most of the remaining length of stay was a very short time. And also, we have a very long tail of longer stay patients, but these get fewer and fewer and fewer. The prediction task that we're doing is a regression task, which means that we're predicting a continuous number, which is the remaining number of hours of the patient's stay. And most commonly, we would use a mean squared error loss function. So what this does is it just takes whatever we predicted. So maybe we predicted 15 hours, but the true value is actually one day. Sorry, 15 days. So if we predict 15 days and the true value is 1 day, that's a difference of 14 days. So we take 14 and then we square it to get the squared error here. Because of this squaring operator, we end up getting an increasing loss with a bigger error. So what that'll do to the model is it will make it want to just always predict a very low value, because most of the length of stay is going to be in this region of 1 to 2 days. There's not going to be many over here. So it's safer for the model to always predict low, and then it will never get this very, very high loss. In fact, well, it won't never, but it will only get this when we have a very long stay patient, and then that's where the error is coming from. So in order to stop the model from just always predicting low, which is not very useful for us because it just won't differentiate between patients, we use a different loss function, which is the squared log error. And this gives us much nicer behavior because it's also penalizing the model for predicting lower length of stay than the true value. So we can see that here, instead of increasing over time with increasing error, it's decreasing on this side, but it's penalizing very strongly for under predicting the length of stay. And that's also, I guess, clinically desired, because if the model says this patient is going to be discharged within 1 day and the true value is 5 days, then the bed manager might plan to put a new patient into that bed, whereas the model is actually under predicting, which is particularly bad. We don't want it to be under predicting too much, because if the bed isn't available, that's more of a difficulty. Okay, so we find that this other loss function behaves much better for our purposes. And I think particularly in medicine, it's very important to think carefully about the problem that you're dealing with. And if there is something like this that you need to change to get it to behave well, it's well worth thinking about the application.